Seasonal variations of light and temperature increase steadily towards the poles. So let's start, we're close to the March equinox. The equator faces sun directly. Neither pole tilts towards the sun. All regions on Earth experience 12 hours of daylight and 12 hours of darkness. So this is the spring equinox in the northern hemisphere. Okay, the June solstice in the northern hemisphere is when the Earth tilts towards the sun and summer begins. This is the longest day in the northern hemisphere. Winter begins in the southern hemisphere. It's the shortest day in the southern hemisphere. Constant tilt at 23.5 degrees. September equinox, the equator faces the sun directly. Neither pole tilts towards the sun. All regions on Earth experience, again, equal hours of daylight and darkness. Then going into the December solstice, the northern hemisphere tilts away from the sun. Winter begins in the northern hemisphere, with this being the shortest day in the northern hemisphere. Summer begins in the southern hemisphere, with December 21st being the longest in the southern hemisphere. Global air circulation. Global air circulation and wind patterns play major roles in determining climate patterns. So an arid zone, here the ascending moist air releases moisture. At the tropics, it's going up. So here these converging air masses, if you've ever flown over the equator, it's very bumpy. And then descending dry air absorbs moisture. So there are these circular air patterns around the latitudes of the Earth. With convergence here at the equator, these again at the Tropic of Capricorn and Cancer, and then up here towards the poles. So with the converging air, we have global winds. So here the southeast trade winds and the northeast trade winds converge at the equator, and the surface of the ocean, this is called the doldrums. It's very, very quiet and smooth. And then the westerlies down here, westerlies here. This is what affects our weather in the United States. Our storms come from the west. Okay? So westerly winds in temperate zones are the results of descending air masses flowing towards the poles, as you can see here. And if the Earth wasn't rotating, these air masses would go straight across. But since it's rotating, they are curved. And the unequal speed of land moving through space at the equator and the poles result in these winds. Regional, local, and seasonal effects on climate. So various features of the landscape, water, mountains, contribute to local variations and differences in climate. Oceans and lakes moderate the climate of nearby terrestrial environments because water has a very high Pacific heat. Okay? It takes a lot of heat to raise water 1 degree centigrade. Therefore, it acts as moderating the climate. So, as experienced in the Mediterranean climate. Seasonal variation also in climate. Bodies of water. Oceans and their currents and large lakes moderate the climate of nearby terrestrial environments, such as in the Atlantic Ocean with the Gulf Stream heading north off the coast of North Carolina. Warm current, it keeps the British Isles from freezing. There are even palm trees that grow on parts of the British Isles. So it's very warm water. Conversely, in the Pacific Ocean, it's cold water that is moving up the Humboldt current. So the Pacific Ocean is colder. So warm air over land rises. Air cools at high elevation. Cooler air sinks, so rises, sinks. Cool air over land moves inland, replacing warm air. So it's this constant flow. Warm air weighs less than cool air, so that's why it rises. Mountains have a significant effect on the weather, the amount of sunlight reaching an area, because with this warm air rising, there has a tendency for clouds to form, so then more storms, local temperature, and rainfall. So here's the Pacific Ocean coastal range, wind direction. Here's Sierra Nevada. You can think of the city of Seattle sitting right here. Okay, here's the Olympic Peninsula with mountains, rain. Seattle here, big Sierra Nevadas, more rain. And then on the east side of this, it's the rain shadow, and the eastern part of Washington State is very dry and arid. So moist air from the ocean cools at higher altitudes and precipitation occurs. Okay, further south, like redwoods are here. Further inland, precipitation increases as air moves up, and you can get deep snow here. The eastern side of the Sierra Nevada, little precipitation, rain shadow produces deserts. So this is prevalent along the west of the United States. In mountainous areas of western North America, south-facing slopes in the northern hemisphere receive more sunlight than nearby north-facing slopes. So they are warmer and drier, so different plants and animals live there. In North America, spruce and other conifers occupy the north-facing slopes because they are more alpine-type plants, whereas shrubby, drought-resistant plants inhabit the south-facing slopes, more Mediterranean-type plants. Also, with a 1,000-meter increase in elevation, the temperature declines 6 degrees centigrade. Therefore, at the equator in Tanzania and Africa, on the eastern part of Africa, Mount Kilimanjaro is covered with a very high mountain. Seasonality. The angle of the sun leads to many seasonal changes in local environments. Lakes are sensitive to seasonal temperature change and experience seasonal turnover, such as in spring and fall, okay, where it's turnover and the temperature is even. In the winter, this settles where it's warmer in the bottom, cooler at the top with ice on the top because ice is less dense than liquid water. In the summer, a thermocline is created where it's much cooler at the bottom and warmer at the top, being by sun. A microclimate is determined by fine-scale differences in abiotic factors. Example, tops of mountains at the equator, hotter than its surroundings. One way to predict future global climate change is to study previous changes. This is the current range and predicted range of the American beach. On the left, this is if it's predicted 4.5 degrees centigrade warming over the next century. The current range in orange, predicted range in yellow overlap the crosshatch. On the right, 6.5 degrees centigrade warming over the next century, you can see it is very, very different. So the current range and predicted range. Abiotic and biotic factors influence the structure and dynamics of aquatic or water biomes. So biomes are major ecological associations that occupy broad geographic ranges of land or water. Biotic and abiotic factors influence these. So biomes. Earth's aquatic biomes account for the largest part of the biosphere in terms of area. They contain fresh water or salt water. Oceans cover about 75% or 3/4 of the Earth's surface and have an enormous impact on the biosphere, moderating the climates all around here and up here around the Great Lakes, lake effect weather, lake effect snows in the wintertime. Okay, many aquatic biomes are stratified in layers into zones or layers defined by light penetration, the temperature, and how deep it is. So this is the zonation in a lake. The lake environment is generally classified on the basis of three physical criteria: light penetration, photic, and aphotic zones. That means where photosynthesis is occurring and where it's not. Distance from the shore and water depth, littoral and limnetic zones, littoral closer, limnetic further out, and whether it is open water, which is pelagic, or bottom, the benthic. And in marine zonation, like lakes, the marine environment is generally classified on the basis of light penetration. Again, photic and aphotic zones, distance from shore and water depth. So you have intertidal, neretic, and oceanic zones, and whether it is open water, which means pelagic, or bottom, benthic, and abyssal zone is very deep, the deepest regions of the floor. The deepest abyssal zone is 6 miles deep off the coast of. The major aquatic biomes: lakes, wetlands, streams and rivers, estuaries, intertidal zones, ocean pelagic biome, coral reefs, and marine benthic zone. So lakes and wetlands, here's a lake in Grand Tetons, Wyoming. Here's Okefenokee Reserve in Georgia. Okay, so physical environment of lakes: standing bodies of water range from ponds a few square meters in area to lakes covering thousands of square kilometers. Light decreases with depth, creating stratification. Temperate lakes may have a seasonal thermocline. Tropical lowland lakes have a thermocline year-round. Wetlands is a habitat that is inundated by water at least some of the time, and that supports plants adapted to water-saturated soil. Some wetlands are inundated at all times, others flood infrequently. Streams and rivers. A stream in Smoky Mountains in North Carolina, large river in the Mississippi River. For streams and rivers, the most prominent physical characteristics of streams and rivers is their current. Okay, this is a faster current here than here. Headwater streams are generally cold, clear, turbulent, and swift, like in the Smoky Mountains. Farther downstream, where numerous tributaries may have joined forming a river, such in the Mississippi River, the water is generally warmer, more turbid because of suspended sediment, and streams and rivers are stratified into vertical zones. So this is a Mississippi River far from its headwaters. Here's a headwater stream in the mountains. Estuaries and intertidal zones. So this is a low coastal plain, an estuary in a low coastal plain of Georgia. And an estuary is a transition area between river and sea. Seawater flows up the estuary canal during rising tide and flows back down during the falling tide. Often higher density seawater occupies the bottom of the channel and mixes little with the lower density river water at the surface. And this is a rocky intertidal zone on the Oregon coast on the right. And an intertidal zone is periodically submerged and exposed by tides twice daily on most marine shores. The upper zones experience longer exposures to air and greater variations in temperature and salinity. Changes in physical conditions from the upper to the lower intertidal zones limit the distributions of many organisms to particular strata or layers, as you can see in this photograph where you have starfish, mussels, and barnacles.